Okay, so let's get started with our first example that we did on paper. And let's see how we do this with Maple. And we're going to go over a couple of little things that I want to point out. And I should mention that some of this stuff is just my habits on working with Maple. Once you have enough experience with it, you can develop your own little tricks. And I'm sure there are probably ways to do these things even more efficiently, but that's how I do it. And you can go ahead and basically start from my own templates if you want. But the more you spend time, the more you will develop your own habits, so to speak, in terms of how you use the technology to help yourself in dealing with the stability analysis of these models whenever you want to avoid the tediousness of computation by hand. So the first thing I want to mention is that in the worksheet of Maple, you need to load the package vector calculus because the Jacobian is part of this package. If you're new with Maple, it might be a little bit frustrating in the beginning because it's very easy to highlight a block with a certain command and fail to actually click enter on the highlighted command. In that case, the cursor can move to the second position or the second row, but the command is not executed. Maple doesn't care which is the place of each command in the worksheet. So that's one of the most important things to keep in mind if you're new with Maple. It does not matter at all where each command is placed in the worksheet. What matters is the execution order. If you go downward, to the bottom of the page and click enter on a command, that's the one first executed, then so on and so forth. So Maple basically will execute or take into account the commands executed in the order you want them to be executed, not where they are placed. So it doesn't matter whether you have one certain command in the beginning of the page, in the middle, or at the end. What matters is what you clicked on last. And that's important if you assign various values to the same variable, for instance, because then the last value assigned is the one that counts. When you hit the with command, a good sign that you actually executed the command is to have the list of all the commands in that package. And so, of course, what I was talking about, the Jacobian, as you can see it here, it's part of that command. Let's move downward. Another thing I want to do is to assign each equation in the system to one variable, because then I can refer to those equations faster if I have a variable assigned to them. So for example, I'd like to call each equation in the ODE system by the initial EQ from equation and then a letter that signifies the dependent variable for that equation. So in that first example that we talked about, we had a system in X and Y. So I'm going to call EQX, equation X, the first equation in the model, which was X times 100 minus X and minus alpha times X times Y. I should point out that Maple can recognize Greek letters if you spell them out. If not, you can choose a different letter like A if you don't like to enter the full Greek name if you want for the letter. So notice that you actually have in the output the Greek letter alpha. And then the equation for Y was alpha times X times Y minus 5 times Y. Once you enter the system, then the next thing to do is to compute the equilibrium points. So you could do that with the solve command. Make sure you don't leave any space between the name of the command and the arguments. So in the parentheses, you're going to enter 2 pairs of braces like that. In each pair, in the first pair, you're going to enter each equation. So the braces, by the way, signify a system of equations. If you have a single equation, you don't need braces. But since we have 2 of them, we're going to put the systems of equations together in a pair of braces. So EQX equals 0, EQY equals 0. And then in the second pair, you're going to specify which variables you want to solve for. So this is like telling Maple, I want to solve the system EQX equals 0, EQY equals 0 for the variables X and Y. hit enter, and we have the solutions that we already computed on paper. So 3 equilibrium points, 0, 0, 100, 0, 5 over alpha, and if you multiply by 5, if you distribute, this is going to be 100 alpha minus 5. So let's say you want to do it with maple this feasibility condition. This is obvious, right, that alpha should be greater than 1 over 20 for this equilibrium to be feasible. But let's say it's not obvious. Let's say you have a more complicated expression. You can always copy and paste and put it in the math mode and either solve the inequality for alpha, so you can write greater than equal to greater than 0, and when you highlight the inequality on the right hand side, you should have some solve command, and then it gives you the solution alpha greater than 1 over 20. Whenever possible, I would advise you to actually use the pencil and the paper for simple equations like this, because it can be overkill if you do every single thing with maple. Maple should be available to you whenever it's not easy to do by hand the computation. So in this particular case, the feasibility condition, I would just basically do it on paper. It's overkill to do it with maple. I can clearly see that this parenthesis is positive if 20 alpha minus 1 is positive, which is the same as alpha greater than 0.05 or 1 over 20. The second, the other command is the Jacobian, and I like to denote that Jacobian by some letter, J, F, whatever you want to do. So the Jacobian, it's very important to follow the syntax. If you go back to the package here, notice Jacobian is with capital J. Maple distinguishes between capital and small letters. The syntax in the Jacobian command is to put in a pair of square brackets the two equations on the right hand side, EQX, EQY. So notice the advantage of denoting these equations in these variables, because otherwise you'll have to write the full equation in each of these components. And then, very importantly, pay attention here in the same order of the variables, right? So you have the Jacobian of these two equations with respect to x and y. So you do partial x first, partial y for the first equation, partial x, partial y for the second equation. So make sure you launch this command before you assign any values to x and y. So this is the Jacobian. And now it's time to assign values to the variables. So colon equal, remember that's the assignment command. So I'm going to assign the first equilibrium to x and y. And now you don't launch again the Jacobian command. Because, by the way, if you do that, you're going to end up with an error. And sometimes it's very difficult to understand where the error comes. This is kind of a subtle thing, especially, and if you're in the beginning with maple, you may be very confused. Jacobian works if x and y are variables, right? So this is basically, the Jacobian is essentially like the first derivative for a vector function. So it needs to have a function as arguments here. Once you assign the value 0 to x and y, as far as maple is concerned, is no longer, these are no longer variables. So basically, it tells you that I need variables here in the first argument, not just 0, 0. So it sees 0, 0 instead of x and y. So two important commands to keep in mind when you run into this type of troubles. One of them is unassign. Unassign essentially clears what you stored in each variable. So put each variable in the apostrophes separated by commas. When you hit unassign, now x and y are again empty as variables. So they don't have a specific value anymore. And now, for example, if you launch again the Jacobian command, is what you would expect to obtain, which is the Jacobian matrix in x and y. If you want to restart with everything, and I'm going to actually enter this command over here. This is probably the first command that you should start with each maple worksheet. The restart command essentially starts over everything, all variables. So you'll have to basically execute all the commands. Sorry about that. Because everything is basically restored to the original state if you hit the restart command. So restart starts over everything, unassign with variable specified, that basically clears the each variable from its values. Okay, I'm going to get rid of this unassigned thing. One variable can be cleared by unassigned or by assigning a different variable, right? So now x and y is 0. To see what is the Jacobian evaluated as 0, 0, you simply enter f again in the math mode. Oops, I forgot to do that. So x0, y0. Now f. Actually, that's another annoying thing with the newer versions of Maple. For some reason, sometimes Maple doesn't actually compute this by default, because really x is 0 and y is 0 as far as Maple is concerned. What you want to do is to highlight the output. The right-hand side basically is a contextual menu. Whatever you highlight, you're going to have commands specified for the, or specific to the highlighted stuff on the right-hand side. I would go, for example, and click on simplify by size. There are many ways of simplifying expressions. So when you simplify the expressions, then you really see the output that you would get when you actually replace x and y equals 0. In previous versions, you would see already 100, 0, 0, minus 5 once you have the actual values. For some reasons, they changed that. So, so you want to highlight and simplify the output to see what the value is. We did already this in the notes. Notice that because the determinant is negative, the trace is, and the trace is positive, the equilibrium is unstable. So you go on paper and write that 0, 0 is unstable. And now you can continue with the other equilibrium values. If you want to save this stuff, you have to write again on a different row the other values, or we can erase this and start over with a new value. So the second equilibrium point is 100 and 0. X is 100, y is 0. Again, enter F in the math mode, simplify, and now I look and I see that the determinant is given by minus 100 times 100 alpha minus 5. So this is what I was talking about, that it's important to start with the determinant. So let's say you want to do this with Maple, highlight, look at the right hand side, you have various commands. One of them is standard operations, and one of them is the determinant. If you want to factor the determinant, again, you can highlight and then choose factor. And for some reason, it doesn't factor. I don't know why. Yeah, from no idea why it doesn't happen. But anyway, you can pull out 500. That's weird. Let's see. Yeah, it should factor, but anyway, if you pull out 500, you will get basically the determinant minus 100 times 100 times alpha minus 5. Yeah, I have no idea why, because this is actually important for later. Let's try simplify by size. That doesn't work either. Anyway, let's see with other examples. Maybe it's a glitch, because that's actually a first. Maybe with variables it's gonna work better. So anyway, this is gonna be, the determinant is going to be positive if this parenthesis is negative, which means alpha less than 0.05, as we established before. Okay, let's go up here, and now I'm going to erase this stuff, and then let's assign the last equilibrium point, and we can copy and paste. So we're going to assign x to the value 5 over alpha, and y the value 5, 20 alpha minus 1, and quantity over alpha squared. Let's compute again the determinant, the Jacobian. Let's get rid of that, highlight and simplify. And again, always use your brain before you actually do anything with Maple. Again, just by inspection, we can see the trace is negative, because minus 5 over alpha plus 0 is negative. Let's look at the determinant with Maple, and it's already in the factor form. And we can see that the determinant is positive if 20 alpha minus 1 is greater than 0, or alpha greater than 1 over 20, which is our threshold, right? So 1 point. Another trick, if you want this in decimals, just put decimal format for one of the entries. So 1 over 20 is 0.05. So the stability is determined by alpha being less or greater than 0.05 for each equilibrium point. And with that, let's finish this part, and we'll do the second part with the epidemic model. Let's finish this part with running this in p-plane, just to check to see that the stability analysis is correct. So when we go to p-plane, I entered already the system here. I put A instead of alpha. And let's place a number greater than 0.05. Let's say 0.1. This should be the coexistence equilibrium in the predator-prey model. So that means both solutions should approach a positive point. And so notice that no matter where you click, it looks like the solutions approaches a certain point here, which you can actually compute. Find an equilibrium point, and in the message window, you will have the value here of the equilibrium point, which is 500. So 50 for X, 500 for Y. Now, let's say I want to check to see if my stability analysis is correct. As soon as I place something less than 0.05, so let's do something close to 0.5. So if it's truly a threshold, anything less than 0.05, let's say 0.04, should indicate that the solution, should indicate that the predator goes extinct. Y goes to 0, X goes to 100. And so notice that no matter where you click, all the solutions sync to the point 100, 0. So the equilibrium point is x100, y0, and that's the stable point. And in all cases, no solution approaches 0, 0, meaning that the extinction equilibrium point for both species is unstable. So with that being said, stay tuned for the final part when we go over the epidemic model. Let's close this.